So I'm just going to say it. We are all just like non-playable characters living inside a simulation coded by a British chess prodigy to figure out the universe.
Right. Well, I checked the math on that, and while reality might actually be an illusion, you're still the one who forgot to unmute your mic on our pre-production call this morning. I mean, I love the chaos, but let's maybe reel it in just a bit.
Okay, fair enough. But look, welcome to today's deep dive, everyone. We have gotten our hands on an exclusive stack of notes on Sebastian Mallaby's 2026 book, The Infinity Machine. And our mission for you today is to kind of shortcut the massive info overload out there. We want to decode the true story of Demis Hassabis, the founding of DeepMind, and this relentless, almost obsessive quest for artificial general intelligence, or, AGI.
Yeah, because this isn't your standard Silicon Valley story. We aren't talking about chatbots designed to write your emails or tech bros trying to figure out how to optimize digital ad revenue. This is a story about a scientist trying to build a literal infinity machine, like a computational tool designed to read the mind of God effectively and decode the fundamental laws of physical reality from the ground up.
Right, and to understand how someone even comes up with a goal, like reading the mind of God, we have to look at how this guy was wired from the very beginning. Because his childhood was incredibly intense. Demis Hassabis wasn't just smart, he was a chess prodigy at 4 years old. Four. He literally had to sit on a phone book on top of stacked chairs just to reach the board. And he was regularly taking down adults in serious competition. I mean, by the time he was 13, he was the second highest ranked player in the entire world for his age group.
And the psychological framing that developed during those early tournament years is just crucial to understanding his later approach to AI. Because the youth tournament circuit in the 1980s and 90s was brutal.
Oh, complete.
We're talking about high-stakes mental combat, where tournament organizers literally placed wooden boards under the table so the kids wouldn't physically kick each other in the shins out of spite.
Wow.
Yeah. And in the midst of this intense, hyper-competitive environment, his father gave him what sounded like standard, comforting dad advice. He said, win or lose, you just need to do your best.
But Demis did not take that as a comforting cliche. He processed it with a staggering level of literalism.
He really did.
He reasoned that the only biological way to prove you have actually given 100% that you have truly done your absolute best is to push your physical body to the exact point of hospitalization.
Just shy of death.
Right, because logically, in his mind, if you can still stand up and walk away after the match, you held some energy back in reserve. He decided there is no 99% mode. It's all or nothing.
And as someone who has spent a lot of time analyzing brilliant, obsessive minds, I have to admit I admire the sheer, unadulterated chaos of a 10-year-old actively aiming for clinical exhaustion via board games.
It's so wild.
But I want to push back on the idea that this is just a quirky anecdote. It reveals a mind that treats rules, absolute limits, and optimization as the fundamental structure of existence. He viewed his own biological energy as just another resource to be maximized on a game board.
He's basically the ultramarathoner of nerds. He took a comforting dad cliche and turned it into an extreme physiological limit. And you really see that intense burden mirrored in what he was reading at the time. He heavily identified with the classic sci-fi novel Ender's Game.
Oh, definitely.
He felt like Ender, this isolated, bullied boy genius who was burdened by adults with the literal weight of saving humanity. That was his total mood. He didn't just want to win games, he felt destined to solve the grand puzzles of the universe.
Yes, and that desire to solve the universe's puzzles is what drives his transition from mastering the rules of board games to trying to master the rules of human consciousness itself. The first major pivot happens when he's 15.
Right, the video game studio.
Exactly. He takes a step away from competitive chess and gets a job at a British video game studio called Bullfrog.
And Bullfrog sounds completely unhinged. The creator of the studio, Peter Molyneux, would occasionally shoot at his own interns with a BB gun while they were coding.
Normal office behavior.
Totally normal. At one point, someone threw a heavy object across the room, missed their target, and shattered the company fish tank, leaving the office covered in water and dead piranhas.
Yeah.
Just a wildly eccentric, rebellious, seat-of-your-pants environment.
Which is exactly where Demis thrives. He works on a legendary simulation game called Theme Park. And here's where he starts pushing the absolute limits of 1990s assembly code.
He didn't just make digital characters walk around on a screen, right?
No, he programmed the underlying logic gates to make them experience simulated biological states. If you put too much salt on the digital French fries in the park, the avatar's internal thirst variable would spike, driving them to go buy more drinks.
That's hilarious.
If the roller coaster's velocity was too intense, they would experience a nausea variable and get sick.
So he went from making digital tourists vomit in a video game to, like, realizing the human soul is just a really complex line of JavaScript.
Well, not exactly. But that specific mechanical optimization translating a human biological response into a rigid line of code sets up his ultimate intellectual turning point. During this chaotic time at Bullfrog, he reads Douglas Hofstadter's Pulitzer-winning book, Gödel, Escher, Bach.
Oh, that is a heavy read.
It is. It's a dense, brilliant exploration of how formal systems like mathematics or music can acquire meaning. And it fundamentally shifts Hassabis's worldview. Hofstadter argues that the human brain isn't magical. It is entirely made of biological matter strictly obeying the laws of physics.
So human intelligence is fundamentally just electrical patterns firing across synapses.
Exactly. It's the biological equivalent of ones and zeros. Therefore, human consciousness possesses no magical biochauvinism.
Biochauvinism, I love that term.
Right. Hofstadter wasn't reducing the soul to a simple script. He was arguing that immense complexity creates the illusion of a soul. If consciousness is just an emergent property of billions of synapses firing in a specific pattern, then there is no mystical barrier preventing us from recreating that exact same pattern in a machine.
If you can understand the architecture of the pattern, you can write the code to simulate it.
Precisely. Hassabis realizes early on that the human mind is flawed. It's biological and limited by our evolutionary senses. To truly understand the objective physics of reality, you have to build an artificial mind that can perfectly perceive it without those biological biases.
So to read the universe, he has to build the ultimate reader, which kind of kicks off the modern AI wars. Having decided to build this artificial mind, he founds DeepMind with Shane Legg and Mustafa Suleyman. And the way he pitches the billionaire investor Peter Thiel is legendary.
He doesn't bring a slide deck, does he?
No. He doesn't show up with a polished slide deck about revenue projections or market capture. He corners Thiel at a loud, crowded party and pitches him by intensely discussing the philosophical tension and relative value between a chess bishop and a knight.
It's such a flex.
It's a huge flex. But moving past the pitch, to understand how DeepMind actually built this architecture, I'm not going to lie, the author is definitely gatekeeping the best parts behind some intense equations. I mean, it took me like 4 cups of coffee just to get through this chapter on adjusting billions of neural net parameters and minimizing error rates. It gets dense.
I actually read that chapter over a single espresso because I thought the math was beautiful. But
Of course you did.
But I get it. To break it down, the tech world was basically split into a few camps. You had symbolic logic, which is basically feeding machines rigid manual rules.
Like if-then statements.
Exactly. And then you had deep learning, which is essentially massive curve fitting, right? Adjusting weights in a network based on historical data until the machine can perfectly categorize an image.
Right, like what Geoffrey Hinton was doing.
Yes. Symbolic logic, the old school approach, falls apart because the real world has way too many exceptions for rigid rules. Deep learning solved that by excelling at pattern recognition. It acts as an incredible, massive cataloger. It can look at 1 million photos of traffic intersections and perfectly identify a stop sign under any lighting condition.
But deep learning is fundamentally a static observer. It maps inputs to outputs based on what humans have already categorized.
Right. Deep learning knows what a stop sign looks like, but it doesn't intuitively know why you should stop.
A massive cataloger doesn't actually do anything in real time. It just tells you what things are.
Precisely. And that brings us to the third approach, which DeepMind bet the entire company on reinforcement learning, or RL.
Which is learning by active trial and error.
Yes. An RL agent isn't just passively fed human data. It is dropped into an environment, it takes independent actions, and it receives a mathematical reward or penalty. DeepMind's massive stroke of genius was combining the perception of deep learning with the decision-making of reinforcement learning.
And this combination is what led to their famous Atari breakthrough. They didn't teach the AI the underlying code or the rules of games like Breakout or Sequest. They didn't tell it what a paddle or a ball even was.
No instructions at all.
Right. They just fed the raw pixel matrices on the screen into a neural network, gave the RL agent control of the digital joystick, and told it to maximize the score variable. And through sheer brute force trial and error, it became superhuman. But wait, I read that the AI kept getting stuck doing the same dumb things over and over because of how it updated its memory. You mentioned Q-tables in our prep notes. How did that work?
So think of a Q-table as a massive dynamic cheat sheet the AI constantly updates. For every possible state in the game, it scores every possible action based on the future reward it expects to get.
Okay, that makes sense.
But the problem was, if the AI only learns from the exact sequence of actions it is currently taking, it gets trapped in a feedback loop, what we call a local minimum. It finds one mediocre trick that scores a few points and just repeats it forever, ignoring better long-term strategies.
So how did they break it out of the loop?
By introducing something called experience replay, they mathematically decouple the act of playing from the act of learning. As the AI played, it would store its raw experiences in a massive memory buffer. Then, completely separate from the real-time gameplay, the neural network would periodically sample random batches of past experiences and learn from them.
Oh, wow.
It was literally mimicking the biological function of the human hippocampus, which consolidates our memories while we sleep and dream.
That is wild. They engineered digital REM sleep.
Hmm?
And all of this foundational architecture culminated in AlphaZero, the AI that completely mastered the games of Go and chess. But the most staggering detail about AlphaZero is that it used absolutely zero human data.
Yeah.
It didn't study millions of past Grandmaster games. It just played against itself millions of times using Monte Carlo tree search, exploring vast branching possibilities. So if traditional AI was like giving a kid a massive dictionary and saying, memorize this, AlphaZero was like dropping a kid in an empty forest with no instructions and saying, figure out the absolute laws of survival from scratch.
That analogy perfectly highlights the limitation of human data. By removing human games from the training process, AlphaZero removed human cognitive biases. It wasn't burdened by our deeply ingrained historical assumptions of what a good or bad chess move was.
Because it learned purely through its own reinforced experience.
Exactly. It discovered completely alien, highly effective strategies that no human brain had thought of in 1,500 years of playing the game.
AlphaZero proved that removing human data actually creates a vastly superior alien intelligence. And that exact realization exposes the critical flaw in the modern AI landscape today. Because right now, the entire world is obsessed with OpenAI and large language models, or LLMs like ChatGPT. When those dropped, it made DeepMind look like they were falling behind. But according to the sources, LLMs are currently hitting a massive, structural brick wall.
They are hitting the data wall. LLMs are incredibly powerful predictive text engines, but their reasoning ceiling is fundamentally tied to the quality and quantity of the data they are trained on. And they are quite literally running out of high-quality internet to read.
Wait, right.
Yes, they have already ingested Wikipedia, academic journals, Reddit, and millions of books. Once you run out of unique human-generated text, you can't just train the model on AI-generated text, or you get model collapse. The AI starts amplifying its own errors in a synthetic feedback loop.
And the escape hatch to the data wall is going right back to DeepMind's bread-and-butter reinforcement learning. The sources highlighted this massive shockwave in the industry in 2025 with DeepSeek R10.
That was a huge moment.
It really was. This is a model from a follower lab that completely skipped human training data for its reasoning capabilities. It didn't read human logic. It used RL to figure out complex math and logic simply by ruminating. It would try different reasoning paths, recognize if it hit a mathematical dead end, backtrack its logic, and learn to verify its own work just to get the reward signal of a correct answer.
It proved that RL is the key to pushing past the limits of human knowledge. And this shift validates what David Silver, DeepMind's lead RL researcher, outlined in his manifesto. He argued that we are transitioning from the era of human data into the era of experience.
The era of experience, I like that.
An LLM is effectively trapped in an echo chamber, regurgitating what humans already know. But an RL agent can interact with real-world objective data environments. It can look at live, high-dimensional inputs from global blood monitors, real-time supply chain logistics, or complex atmospheric climate patterns.
Oh, man. So we're moving from a giant autocomplete engine that just summarizes Wikipedia to an AI that actually thinks in the shower.
Yes, and it can test hypotheses in the real world, observe the outcomes, and adjust its understanding based on objective feedback, not human opinion. It is moving from mimicking human knowledge to discovering entirely new objective knowledge. And this underlying mechanism brings us to the absolute climax of Demis Hassabis' entire mission.
The real endgame.
Exactly. Why did he spend decades building this? What is the ultimate application of an agent that learns through experience?
AlphaFold. This is the ultimate proof of concept.
Yeah.
Hassabis ended up sharing the Nobel Prize in chemistry because DeepMind's AlphaFold solved the 50-year-old protein folding problem. And the way they did it is mind-blowing. They didn't approach biology like traditional chemists mixing compounds.
No, they didn't.
They treated amino acids like a vastly complex spatial optimization game. Just like AlphaZero navigating millions of possible board states, AlphaFold navigated the billions of ways a protein could physically fold, treating it as a search problem. It proved that AI isn't just a tech product to sell ads, it is a meta-tool for scientific discovery.
But Hassabis's motivation goes even deeper than solving biology. He views science as a deeply spiritual endeavor. He heavily references philosophers like Spinoza and physicists like Einstein, saying that doing science is akin to reading the mind of God. He truly believes that information pure data is the fundamental building block of reality. Not matter, not energy, information.
And this informational view of the universe leads to his intense intellectual clash with the Nobel-winning physicist Roger Penrose.
Right.
Penrose argues that human consciousness and human intuition cannot be replicated by a machine. He relies on a theory that consciousness is fundamentally non-computable, emerging from mysterious quantum superpositions inside the microscopic microtubules of our brain cells.
Penrose essentially believes that true intuition requires the unpredictable fuzziness of quantum mechanics.
But Hassabis aggressively counters this. He says absolutely not. He argues that classical computers operating on strict ones and zeros are Turing complete, meaning they can efficiently simulate and discover any computable pattern in nature all the way down to the subatomic Planck scale, which is the absolute smallest measurable limit of physical reality.
All the way down.
So if everything down to the Planck scale is just data, is he basically saying the entire physical universe is essentially a highly compressible zip file, and AGI is just the optimal software built to unzip it?
That is actually a brilliant way to conceptualize it. Hassabis literally views the physical universe from a computational perspective. Think back to his teenage years designing video games. In a highly optimized game engine, you don't render the digital trees or mountains that the player isn't currently looking at. It would waste massive amounts of computing power.
Right, the game only calculates what is necessary for the experience.
Exactly. Hassabis suggests that physical reality might operate on similar informational efficiencies. If the universe is fundamentally built on computational information, then an artificial intelligence that perfectly processes information without human biological limits is the ultimate key to understanding existence.
That is just mind-blowing. The ultimate takeaway here is that AGI isn't just a neat piece of software to generate deepfakes. In the eyes of its most driven creators, AGI is the ultimate scientific telescope. But instead of pointing it out at the stars to observe light, it is designed to observe the unseen, underlying source code of reality itself.
Which is why understanding the mechanics behind it is so crucial. And to help ground these massive concepts for you, the listener, I have a specific homework assignment for you.
Wait, you're assigning us actual homework? You're totally killing my vibe with this assignment? That sounds way too much like actual work. I thought the entire point of AGI was so I wouldn't have to think anymore.
If you want to truly grasp why DeepMind had to abandon rigid rules and rely on experience, you have to do this. Psychologist Daniel Kahneman popularized the concept of System 1 thinking, or fast, automatic, entirely unconscious intuition. Today, I want you to take one purely intuitive System 1 decision you make effortlessly.
Like what?
It could be instantly recognizing a childhood friend's face in a crowded room, or the instinctual physical adjustments you make while parallel parking your car. I want you to sit down with a piece of paper and try to write out the exact rigid step-by-step mathematical algorithm you use to execute that action. Write down every single variable your brain processes.
Oh, that's impossible.
Exactly. You will fail. But in failing, you'll understand exactly why human intuition is so incredibly hard to code manually, and why intelligence requires an agent to learn through raw, unguided experience instead of human rules.
Okay, that is actually a fantastic exercise. But as you tackle that, I wanted to leave you with one final, lingering idea to mull over on your own. We talked about how AlphaZero discovered completely alien, brilliant strategies in chess simply by playing against itself, strategies that no human brain had conceived of in 1,500 years.
Right.
So what happens when an AGI applies that exact same zero human knowledge, trial and error approach to the laws of physics, to genetic biology, or to the global economy? Will it discover fundamental truths about our physical reality that our biological brains physically lack the sensory capacity to ever comprehend?
It's a profound question. If the universe really is an intricate, computable system of information, we might finally be building the mind capable of reading the code.
Just remember, if reality really is a simulation coded by a chess prodigy, try your best to be one of the useful NPCs. Thanks for exploring the depths with us. Catch you on the next deep dive.